Hi, today's lesson is going to be on specific heat capacity and then some math problems that go with specific heat capacity. The equation that we're going to be using today is Q equals mc delta T. Let's go through what each of these letters mean. Q is the heat energy. Joules is the unit that we use to describe the heat energy. M is the mass of the substance, and that's going to be in grams, and we're going to use a G for the grams. C is the specific heat of a substance. Usually we use water. The unit that we use for this C, which is the specific heat capacity, is joules divided by grams times degrees Celsius. If you carefully look at your reference table, on table B, we can get a real close-up of these constants for water. You will find that you have the heat capacity for water on this table. It's 4.18 joules divided by grams times Kelvin. We spoke about that we can change those units to joules divided by grams times degrees Celsius. So it's on the table for you to use. And then we have the delta T. The delta T is going to be our change in temperature. You have a final temperature minus an initial temperature. The unit that we use for this type of equation is degrees Celsius. The first sample problem, you might want to take a moment and write it down, is determine the heat energy required if 30 grams of water must be raised 15 degrees Celsius. The first step is always to write the equation down. So you can write the equation down. If you're not sure what the equation is, you can check on the reference tables. Table T has Q equals mc delta T on it. The next step is write down the given variables. So the variables from the problem, if you take a look, you have your Q value, which is what we're trying to find. M is the mass, that's 30 grams. And then we have our C, which is from the reference table for water, 4.18 joules divided by grams times degrees Celsius. And the delta T is 15 degrees. The third step is to substitute the values and the units into the equation. Lastly, we're going to solve. So I'm going to show you the substitution and the solved answer. Oops, sorry. Go back. All right, let's just be able to get it closely. So, take a look. Here's your substitution. You're going to put in the numbers with the units. Then, to solve it, you're going to cancel out your units first. So if you look at this carefully, notice what was done. Took the grams here and we divided by grams there, so those units cancel. You have the Celsius here, again divided by Celsius here, those units cancel. We're left with this unit, the joule, which is the unit that we need to find Q. So we're doing it right. So we know that Q is going to be some number with the joule unit. You probably got a number like 1,881. However, we have to round off, dealing with significant figures, to 2 significant figures because the problem had only 2 significant figures. And then you have your final answer. Q is equal to 1,900 joules. That's sample 1. Let's take a look at sample 2. Sample 2, again, take a moment to write it down, asks, calculate the heat absorbed of 25 grams of water, initially at 40 degrees, was raised to 85 degrees. So to solve the problem, start out by, first step always, writing the equation. So Q equals MC delta T is the first thing you should write down. The next thing you should write down are the givens. See if you can do this yourself first. Now, take a look. Q is our question mark. M is our 25 grams. C, the heat capacity is from the reference table, 4.18 joules per grams degree. And then we have delta T, which is a little bit different this time. This time, we're given a final and initial temperature. Therefore, you had to take the final temperature minus the initial temperature and get the change in temperature, which is our 45 degrees. Right there, 45 degrees. Now we substitute. Right here, take a look. Let's go back a second. And let's see our substitution. Substitution is right there. We substitute in the numbers, and then we're going to cancel out the units. See if you can do that yourself. And then we're going to solve it with our final answer. We know that's in joules once we get all the units taken care of. You probably got something like 4,702.5 joules. We have to round that off to 2 significant figures, and we end up with an answer of 4,700 joules. Can you do that on your own? Hopefully you can, because in sample 3, here we go, sample 3, take a moment, write down the question. Question says, how many grams of water would be needed for 1,000 joules of energy to be released, to be released from a 15-degree change in temperature? Again, you can take a look at this, pause it. How many grams of water would be needed for 1,000 joules of energy to be released from a 15-degree change in temperature? Well, same steps. Let's solve. So you go and you write. What do you think you write first? I think you know. Exactly. You write the equation. If you don't know what the equation is, where do you go? Write again, table T. There it is, Q equals MC delta T. It looks like MCAT. Now you put in your givens. This time we have Q. We didn't have that before. Now we do. We are looking for the mass this time. We do have the heat capacity as usual because we are talking about water. And then lastly, the change in temperature is 15 degrees. One little difference this time. Well, here we go. You will complete this problem for homework. Bring the completed problem to class tomorrow. Okay, see you then.